Welcome back to Year 11 Chemistry. Today we're going to be talking about reactivity of metals and ranking metals in terms of that reactivity, and then looking at an example of metal displacement reactions. So in chemistry, reactivity is usually talking about how readily an atom or a compound undergoes chemical change. So we can be a little bit more specific with metals. So we've seen that metals can lose electrons or gain electrons, so they can undergo a redox process. But they are very selective in which metals they lose or gain electrons from. The metals have to lose their electrons to a less reactive metal. That's the only way they are going to undergo a redox reaction. So basically what we can do is rank metals in terms of their ability to lose their electrons to other metals. So let's have a look at an example of this reaction. So we've got a copper wire being placed into a solution of silver nitrate. So slowly over time we actually see that copper is being leached out of the solid copper. So we can see that because we have a colorless transparent solution beforehand, and then it transforms into an opaque sort of blue solution due to the copper 2 ions. So what we can do is actually simplify this a little bit more, because the nitrate in the silver nitrate solution is actually what we call a spectator ion. It doesn't actually get involved with the chemical reaction, so we just call it a spectator. So we can simplify this reaction a little bit more so we can see clearly what's happening. So beforehand we just had copper solid, so that's our copper there, and a silver 1 solution. Slowly over time our copper transformed into copper 2, which we can see from the blue solution, and we have a deposition of silver solid at the bottom of the test tube. So we're just going to have a look about why this occurred. So we're given a metal reactivity series in chemistry, so we can see that we have our silver and our copper very close together, but all that matters with metal reactivity is that there is a ranking. So we can see that copper is more reactive than silver. So we expect that copper will lose its electrons to silver. So we're going to look at the copper-silver reaction in a little bit more detail. So to form the two half equations from this full redox equation, basically we start with one of the half reactions first. So we see that we've got a reaction to give from copper to copper 2, and then a reaction to go from silver to silver. So we can just pluck out the two half equations. So let's just start with all the copper first. So we have copper going to copper 2 plus, and then we follow our same processes for balancing our half redox equations. So this whole reaction is balanced, this copper to copper 2. The only thing that is not is the charge. So we balance the charge by adding 2 electrons. Next, we'll do the silver half equation. So we have silver plus going to 2 silver. So we can write that in a half equation. Same process, everything's balanced except for the charge. So we have 2 positives on the left-hand side and a neutral on the right. So therefore we add 2 electrons. So now we have a more of an idea of what's actually occurring. So we can see that copper has lost its electrons and has been oxidized. So this has to occur because copper is the more reactive metal. Silver ions have accepted their electrons, so silver ions have been reduced. This is all due to silver being the less reactive metal. So overall, we're only going to see these metal displacement reactions when, for example, the solid metal, so copper in this case, is the more reactive metal. If it was solid silver reacting with copper ions, we wouldn't have seen a reaction. It just would not react. So the solid metal always has to be the more reactive metal for this reaction to occur. So let's have a look at a few more examples. So we've got aluminium and lead chloride. So we've got a solid aluminium and a lead chloride solution. And so we see that aluminium is paired with lead. So we see that the solid aluminium is the more reactive metal because it's higher up in the ranking. So we're going to see a reaction for aluminium and lead. But if we have a look at quickly at the silver and the iron, so we see that silver being the solid is lower than the iron in the reactivity series. we're going to see no reaction occur with the silver and iron. So let's have a look at the full equations. So we can see that we have aluminium going to aluminium 3 plus 3 electrons. Usually the aluminium 3 plus will be given to you in the question. And then lead 2 is going to lead, so we just need to balance by adding 2 electrons. Overall, we need to balance by making the number of electrons in each half equation the same. So we just times this whole aluminium equation by 2 and this whole lead equation by 3. And if we combine the result of that, we should achieve 2 aluminiums and 3 leads going to 3 aluminium, 3 and 3 lead solid. And we can further flesh this equation out by adding in our spectator ion from before to achieve the full equation. And as we saw before, silver is actually below iron in the metal reactivity series, so no metal displacement reaction will occur. So a solid piece of silver sitting in iron sulfate solution will actually sit there forever. It will not react. So that is a short lesson today. So thanks again for listening. Don't forget to like and subscribe. Next time we'll be actually looking at the application of metal displacement reactions in galvanic cells. Thank you. See you next time.